Hello, in this video we are going to see about continuous random variables and maybe a problem or an illustration based on this. Starting with the basic definition of continuous random variable. I am G. Lavanya, Department of Mathematics, and I work as an assistant professor and I am offering this video to you. So what is a continuous random variable? In my previous session, we were talking about discrete random variable. Now, when we talk about continuous random variable, what happens is x takes infinite number of values. So, a random variable x which takes all possible values, which takes all possible values in a given interval, in a given interval is called continuous random variable, is called a continuous random variable. So this is the simplest definition. Some examples could be age, height, weight, etc. These are all continuous random variables. These are all continuous random variables. Now, what is probability density function? There we learned what is a probability function, right? Corresponding to that, in continuous case, you have something called as a probability density function. So what is a probability density function? PDF. So continuous random variable x, let us specify on a certain interval, let us say a comma b. Okay, so consider a continuous random variable x specified on an open interval a comma b. However, it can also be infinite. I am taking some a comma b. Okay, it can also be minus infinity comma infinity. That is also allowed. Now divide this interval into sub intervals. Divide this interval into sub intervals. Okay, the width of that each interval or the sub interval's length is given by, I will have, let me denote by delta xi minus 1 equal to xi minus xi minus 1. This will give the length of the sub interval by arbitrary points, by arbitrary points, let me say x0, x1, x2, etc. I have only finite AB, no? So I stop with some xn. So let us now assume that the probability, let us assume that the probability that our random variable x, probability that our random variable x will fall in xi minus 1 comma xi. Then how do I denote this? Then this is denoted by probability of, I will have xi minus 1 strictly less than x less than xi. This is how it is denoted. You can represent this as, you may represent this as area of a rectangle, as area of a rectangle with base. Base will be the difference of this. So that would be our delta xi. Base will be delta xi. Now for each interval we can determine. Therefore, for each interval, what will be the previous interval xi minus 1 comma the next to point xi. That will give the interval. So as I increases, you will get next intervals 0, 1, 1, 2, 2, 3, so on. We can determine the probability of x falling in each of these intervals. So for each interval, we can construct an appropriate rectangle. We can construct an appropriate rectangle. Okay, so when you consider this, you will get and arrive at a figure like this. This would be your x-axis. You will have your 0 point or your origin here. You will have x0, then you will have x1. Similarly, you will have x2, then you will have some dot 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 dot. Finally, let me say I will have xi minus 1, then I will have an xi, and then again I will proceed. Maybe till I reach somewhere over here, again I will have a rectangle over here, let me say, where I will have xn minus 1 to xn. So this is how our figure will get generated. So this is a step like broken line that we are having. So if you have a function y equal to f of x, such that I will have my limit as this delta x tends to 0, my probability of x strictly less than my random variable x strictly less than this incrementation point x plus delta x divided by delta x. This will be given by f of x. This is termed as the probability density function or PDF. I hope you would have got an idea of how to generate the PDF for a continuous random variable. Okay, so it is also known as the probability density function, is also known as frequency function. It is also known as frequency function or distribution density or distribution density. These are all other names given to it. We will be sticking on to PDF. That is the most common way. Okay. So here the curve y equal to f of x, the curve y equal to f of x is called probability curve. It is called the probability curve or the distribution curve. It is called probability curve or it is known as the distribution curve. Okay, right. Now, if you know PDF, how will I find a cumulative density function? That would be the next thing. In the case of a continuous random variable, if you integrate the PDF, you will get the cumulative distribution function, in our case between the interval a and b. Okay, now let us go for a small remark. If f of x is a PDF of random variable our capital X, then the probability of the random variable x will fall in some interval alpha comma beta is equal to probability of alpha strictly less than x less than beta. So this is nothing but you will be summation in continuous cases integration. So you will run from integral alpha to beta f of x dx. So this is how you get it. Next, properties of PDF. Properties of probability density function. Number 1, always your f of x will be non-negative, that is, it will be greater than equal to 0. Your f of x will always be greater than or equal to 0 wherever your x lies. So minus infinity, less than x, less than infinity. Second subdivision, integral minus infinity to infinity, your f of x dx, this is almost the same as total probability. So this value equal to 1. Number 3, if E is any event, if E is any event, then P of E equal to integral over E f of x into dx. Okay. Now, if it's an interval, we are saying all this. Suppose it is a point, then what happens? So, we will discuss that remark. We know that if x takes the value 5, we can get a value for p of x if it's a discrete random variable. But in the case of a continuous random variable, the probability at a point is always 0. The probability at a point, say x equal to c, for a continuous random variable, for a continuous random variable is always 0. Why? This width of the interval, you say no, from where to where, that width becomes 0. Since, see, here how you are defining between alpha to beta. If it is only one point, this width itself will become 0. Both the points are coinciding. Therefore, this continuous random variable will always take the value 0 when you consider it at a particular point. Okay. Then the second main remark will be, if x is a continuous random variable, if x is a continuous random variable, then we have probability of alpha less than or equal to x less than or equal to beta will be the same as probability of alpha less than or equal to x strictly less than beta equal to probability of alpha strictly less than x less than or equal to beta, and it will also be equal to probability of alpha strictly less than x less than beta because it is continuous. Okay, it is not true for discrete random variable. We have already seen it with our numerical examples. Right, we will close the session by doing one small problem to illustrate how to find our PDF. Okay, so problem number 1 is, we will first check whether a given function is a PDF or not for a continuous function. Is the function defined as follows, is the function defined as follows a density function? Okay, so our f of x equal to e power minus x for x greater than equal to 0 and 0 otherwise. Your second subdivision, if so, determine the probability that the variate having this density will fall in the interval 1, comma 2. Right. Now let us proceed with the problem solution. What do we know? We know that the interval between minus infinity to infinity f of x dx should be equal to 1 if f is a PDF. Now, where is my interval running? Minus infinity to infinity. So, minus infinity to infinity, f of x dx can be very well split as minus infinity to 0 f of x dx plus integral 0 to infinity f of x dx. This value equal to 0 and this value is e power minus x. Therefore, this is integral 0 to infinity e power minus x dx, which is e power minus x by minus 1 between 0 to infinity. E power minus infinity is 0 and e power 0 is 1. So one more negativity for the lower interval, which gives you the answer as 1. Therefore, it is a PDF. It is, since the value equal to 1, it satisfies the conditions of the density function and hence it is a PDF. Now let us go to the second part of the question. What is this? Probability of 1 less than or equal to x, which is less than or equal to 2. So my alpha beta here running will be from 1 to 2. I want to find f of x dx. I know that 1 to 2 lies between 0 to infinity. See, 1 comma 2 belongs to the interval 0 to infinity. In this range, what happens to the function? The function is taking e power minus x value. So this is equal to integral 1 to 2 e power minus x dx. So this is e power minus x by minus 1 between the range 1 to 2. So this is e power minus 1 minus e power minus 2. So this value, if you use your calculator, you will get it as 0.368 minus 0.135. Upon simplification, the value that you get would be 0.233. I hope in this video you would have come to know about continuous random variable, properties of continuous random variable, and a short problem to understand continuous random variables in a much better manner. Thank you.